All right, everybody, welcome. Welcome to AMS Weather Band's latest webinar. And this is inside the NOAA NWS Storm Prediction Center, Operations and Future Services with Bill Bunting. Now, before we start, Bill and I would like to take a moment to have everybody introduce themselves. Just kidding. Bill, that was for you. Before we begin today, I would like to address some of the ground rules for our webinar. First, if you have questions during the webinar, please put them in the Q&A. If you look at the bottom of your Zoom screen, you'll see where the chat button is, and to the left of that should be a button that says Q&A. Please make sure that all your questions are placed there. That's what we'll be paying attention to as the webinar progresses. So if you have something pressing on your mind that you would like to ask, that's where you're going to go. Any questions or comments submitted through the chat option will not be considered. It'll be seen, but won't be addressed during the webinar. But yes, so please keep that in mind. Pressing questions, Q&A. Also, kindly keep your cameras off. And we will have some specific time for questions from the audience. We'll actually address that as the webinar progresses. So without further ado, I would like to introduce today's guest. Thank you, Bill, for joining us today. Ladies and gentlemen, Bill is a native of Virginia Beach, Virginia, where an early interest in hurricanes sparked a lifelong interest in all forms of severe weather. A graduate of the University of Oklahoma with a bachelor's degree majoring in meteorology and psychology, Bill has worked for the National Weather Service for over 36 years, primarily in the Central and Southern Plains at offices in Oklahoma City, Kansas City, and Fort Worth. He is currently the Chief of Forecast Operations at the NOAA NWS Storm Prediction Center, where he is responsible for all watches, outlooks, and mesoscale discussions produced by the center's 22-person forecast staff. Now, in addition to severe thunderstorm forecasting, Bill's other weather-related interests include storm damage assessment and the role of expertise and judgment in the forecast decision process. All righty. With that being said, Bill, the floor is yours.
Excellent. Thank you, Gideon, and thanks, everyone. Hello from the Storm Prediction Center. Give me just a second here to activate my screen. And let me just verify that everything is working. Can you see the screen okay?
That is, yes, that is correct, Bill. We're good.
All right, I'll go ahead and get started. My presentation today is, it's a broad overview of the Storm Prediction Center. It's a bit about our daily operations. It's a bit about our future services. I won't dwell much on the details of the forecast process. I'll speak about it, but really you could have more than just a seminar. You could actually have an entire college course on the aspects of forecasting that we employ here. But my goal is to give you just an overview of what it's like to work here. And I hope to do that here in the next 45 minutes. These are the topics that I will cover, not necessarily sequentially. Talk just a bit about our mission and our brief history, our daily operations, the forecast process from an overview perspective, talk about how to interpret SPC convective and fire weather outlooks, and then end with just a glimpse on our plans for future services, how those will evolve over the next, say, 3 to 5 years or beyond. Before I go any further, I just want to thank some folks here at the SPC, the Director, Russ Schneider, the Science Support Branch Chief, Patrick Marsh, our Science and Operations Officer, Israel Iraq, and our Warning Coordination Meteorologist, Matthew Elliott. They were all very helpful in putting these slides together and certainly the background information that I'll present here today. Thought I would start with just a quick, concise version of our mission. Our mission is very simply to forecast tornadoes, thunderstorms, and also fire weather conditions nationwide. A lot of folks know that our mission is tornado and severe thunderstorm forecasting, but not everyone knows that we also play a significant role in fire weather forecasting for the lower 48 states. We do that by forecasting information that's valid from a few minutes out to 8 days into the future, because one thing we know is that advanced planning depends on adequate lead time, and increasingly that's measured in days, whether it's dangerous fire weather conditions or a looming threat for severe thunderstorms. And to do these things, we partner very closely with 116 of the 122 local National Weather Service offices that collectively cover every inch of real estate of the United States. We don't forecast for Alaska, Hawaii, Guam, Puerto Rico. So our focus primarily is with the CONUS, or the conterminous United States, 116 WFOs. The Storm Prediction Center is part of the National Weather Service known as the National Centers for Environmental Prediction, or NCEP for short. We are here in Norman, Oklahoma. There are 8 other centers, the National Hurricane Center in Miami, Space Weather Prediction in Boulder, Aviation Weather in Kansas City, and then a collection of NCEP centers in College Park, Maryland, that handle a variety of aspects of what the National Weather Service does, ranging from running models to weather prediction, snowfall, rainfall, basic map forecast, climate prediction center, and then of course our central operations. And then for interest in the marine areas of the country and the offshore waters, the Ocean Prediction Center is also in College Park. So collectively part of the National Weather Service, but these are centers of expertise, centers of excellence, focusing on their particular mission. The SPC is located here in the National Weather Center in Norman, Oklahoma. By far the nicest office I've worked in my career. This is on the South Research campus of the university. And what I mainly wanted to point out here with this slide is the co-location with so many other components, not only within NOAA, but also within the School of Meteorology and other entities as well. A big part of what we do here at the Storm Prediction Center is the applied research, advancing the science through collaborative research, through the hazardous weather test bed that I'll talk about here shortly. And it's easy to do that in a facility such as the National Weather Center building. If you're ever in central Oklahoma and once the pandemic restrictions completely wind down, there are public tours available, and certainly encourage you to take that tour if the opportunity presents itself. This is a close-up view of our operations area. It's a small staff. It's 34 federal employees, 22 forecasters, as Gideon mentioned, 7 science support branch staff, 5 front office managers, including myself. And then we have a small group of very dedicated Cooperative Institute research scientists who help us with particular challenges or needs that we may have. We have a couple of contractors that help us as well, but really it's a pretty small group. The picture is taken from a hallway where all of the tour groups stand as they visit the building. And a common refrain that I would hear from the tour groups is, I thought this place would be bigger, more like Mission Control in Houston. And I thought that was interesting because I've been to Mission Control in Houston at NASA. And my first thought was, I thought this place would be bigger. So it's a small group. It's a very focused group. We can do the job with relatively few folks because every day is a severe weather day here at the SPC. Certainly from mid-May through the middle to latter part of August, every day there's a severe weather threat somewhere. And so we get used to a very quick operational tempo, being able to focus on multiple threat areas and do our job at a high level. During the daytime right now, there are 6 forecasters on duty. In the overnight hours, it goes down to 3, and actually for a few hours, it goes down to 2. And we can adjust that staffing as needed based on the particular weather concerns on a given day. I thought it was worth just giving a couple of words on the history of tornado forecasting in the US. It's a very interesting history, not at all what I would have expected as we looked into it. First, I'll just say that in the early part of the 20th century, the Weather Bureau, as we were known at the time, was prohibited from using the word tornado in a public forecast or statement. There were widespread beliefs that the word tornado would cause more panic than it would produce in benefits. One Chamber of Commerce official was quoted as saying that use of the word tornado creates unfavorable publicity. Interests are best served by refraining from its use. And so even after the prohibition was lifted in 1938, it still wasn't used very often. And then a couple of events happened in quick succession in 1948 that changed the world of severe storm forecasting. And I often wonder where we'd be today if these events hadn't happened. On March 20th, a tornado hit Tinker Air Force Base without any warning, causing considerable damage to buildings and aircraft. The base commander told the 2 weather officers who you see here Major Ernest Fawbush and Colonel Robert Miller, to provide heads up the next time they saw those dangerous conditions developing. Well, incredibly, 5 days later, when they saw similar conditions, they alerted the base commander, who took action, flew aircraft out of the way, and against all odds, a tornado hit the same exact area 5 days later. And it was from this humble beginning, two forecasters with an interest in severe storms, but without much of an organizational emphasis on forecasting them, were able to do this. And it changed the way, certainly the US Weather Bureau, military weather forecasters looked at severe storm forecasting. The Air Force was first to start their own national severe weather forecast unit. The Weather Bureau followed a few years later, and we've been here 24/7 ever since. So it's a fascinating history. There's more on our webpage. Fawbush and Miller are considered really meteorological gods when it comes to their early publishing and just their ability to focus on the hazards of severe storms. And in fact, a few years before Colonel Miller passed away, he stopped by the SPC, spent some time with our forecasters, did his own manual map analysis, autographed it for us, and it hangs in the hallway at the entrance to our operations area. So a very long history and a proud tradition of manual analysis, which I'll talk more about here as we move through the presentation. Even in today's world of largely automated weather information, there's a role to play for map analysis by hand and a pencil box with the ability to illustrate and highlight features of interest when it comes to severe storm forecasting. Given our nationwide risk, and this is a map just of the reports from 2021, tornado reports in red, damaging wind reports in blue, large hail reports in green. You can see that for most of the US, the question is not, will there be severe storms in a given year? It's just a question of when, what time of the day, and how bad could it get? This map makes it pretty clear that if you live along and east of the Rocky Mountains, it's a question of, what day should I focus on, not will I have severe storms? I think even west of the Rockies, it happens more frequently than we have the data to suggest. It's just that with lower population density, we don't know about all of the reports that exist. And so you can see that the central US and really eastward through New England and the Southeast, frequent concerns about the risk for damaging winds, large hail, and on many days a year, tornadoes. The graph at the lower left actually shows the breakdown of the number of reports by day. And the first thing you can see is that we have a traditional season. Of course, spring and through the summer, there are daily reports virtually, and then days of more concentrated, higher numbers of reports. But what you see here that's interesting is in December, which is historically, it can be active, but oftentimes it's fairly quiet. December 2021 was a historically active tornado month with deadly tornadoes, unfortunately a very high death toll, and multiple days where there were large numbers of tornadoes occurring. So it's the climatology of severe weather is important to know, but also the limitations as well. In this graph, I just wanted to illustrate the distinction between the more common shorter-lived tornadoes that are towards the lower end of the enhanced Fujita scale, EF0s and EF1s. The lighter blue bars show the percentage of all tornadoes in that EF scale category. And then you'll see that as we move towards the right, EF3s and higher, they account for a really small percentage of all tornadoes, but they account for a disproportionately high percentage of tornado deaths. And so here at the Storm Prediction Center, while our focus is on severe storms in general, any storm that produces quarter-size hail or larger, 58-mile-per-hour winds or higher, and of course tornadoes, our real concern is with the upper end of that spectrum, strong and violent tornadoes, EF2 or greater, and the storms that produce high-end damaging winds and exceptionally large hail, say 2 inches or larger in diameter. In this animation, you will see the progression of the risk of a tornado. These are 10-day increments, so you can see where the animation started. There was a low but not zero probability in the Southeast US. And then as we go ahead through another cycle here, beginning now, the climatological incidence increases and spreads west and then eventually north. And what's interesting is that this is a very useful way to determine, in a general sense, when my risk might exist and when it peaks. But if you look at mid-December, say right now in Western Kentucky, it's a very low probability. yet December 10th of last year, we had a historic tornado outbreak. So my caution here is that the probabilities, the climatological probabilities, very useful information. However, the atmosphere doesn't always pay attention to the calendar. And that's why if you are concerned about severe weather, if you're planning to be in a location that's vulnerable on a lake, a golf course, working outdoors, knowing that you've got to monitor the forecast on a daily basis, not just be aware of historically when your season tends to peak and when it wanes. By the way, these climatological probabilities are important for interpreting our outlooks, which I'll get to here shortly. So I wanted to quickly go over the primary forecasts that the Storm Prediction Center issues. We're probably most widely known for our severe thunderstorm and tornado watches. The issuance of these watches goes back to 1952. However, they weren't called watches back then. They were called severe storm or severe weather bulletins. We didn't start calling them watches until 1970, after the Palm Sunday outbreak in 1965. Our convective or severe thunderstorm outlooks have been operational since the mid-1950s, at least for the current day. We refer to today's outlook as day one. And then as the science advanced, as our understanding of severe storms improved and modeling capabilities allowed us to do it with skill, we added a day two convective outlook in 1986, a day three outlook in 2001, and then in 2007, a day 4 through 8 outlook. One thing we know is that increasingly, folks want as much heads up as possible, not hours, not a day or two, but ideally, and certainly for the larger scale outbreaks, 5, 6, even 7 days into the future. And so we've responded with an increase in our outlooks to try to provide that information. In the mid-1980s, we added a product called the Mesoscale Convective Discussion, MCD, or MD even for short, that was mostly technical, but does have a plain language component, letting you know what we're thinking regarding the potential for a watch to be issued and other aspects of today's weather as well. And I'll talk about that in more detail here shortly. And then in the late 1990s, we were asked to begin providing fire weather outlooks for the US, and we did that. And we've grown in our coverage area, not just in our coverage time, from day one out through now day 3s through 8, because so many decisions in the land management and planning for fire realm depend on resources being moved, and it takes days, not hours, to do that. And so the more advanced notice that we can provide, the better equipped a lot of folks are to respond to fires when they start. One thing we do know is that SPC forecasts are widely used across not just the weather enterprise, but across, in general, folks with an interest in weather are probably going to see our outlooks in one capacity or another, if not directly from the SPC, through a variety of other means, including graphics produced by local National Weather Service offices, broadcast media, blog posts, social media posts. And so it's something that we take very seriously. When we are preparing an outlook, we will have intense internal discussions. I'll go into more detail here shortly when I talk about the forecast process. But we realize when we hit the send button on that outlook, that it's going to be viewed by a lot of people. It's going to influence decisions. It even has an economic cost in many parts of the country where schools and businesses may opt to close early given the threat. So it is a responsibility that we take very seriously, and really put all the effort that we can, both in terms of using the tools that are available today and developing tools that don't yet exist so that tomorrow's forecast can continue to be of the highest quality. The words that we use to communicate risk have evolved somewhat over the past 50 years, but in many respects, they've remained the same. The words slight, moderate, and high risk, which have been around for almost 50 years now, obviously well predated the internet era. It predated the time when anybody could look at an SPC outlook. And so the words that we chose at the time could be almost any words. And as long as we define them for the few folks who could see them, the meaning could be easily understood. In 2014, we added marginal risk. We also added enhanced slight, which we typically abbreviate enhanced, to illustrate, in this case now, a 5-tier approach to conveying risk. And the 5 tiers basically are a function of coverage. There is an intensity connection here, but it's mostly coverage. As we go from marginal risk to high risk, the odds of you personally being affected do increase. But a marginal risk doesn't mean that these are marginally severe storms. Sometimes it does, but there are occasions where we can have very isolated, very severe storms. And so, again, it's important to know that these words are mainly a function of coverage. They're underpinned by probabilities. And I'll show you the table here in a second that converts those probabilities into those words. And in fact, this is we call it prob to cat, probability to categorical conversion chart. I don't expect you to memorize this. I'm just going to show it briefly, but it is on our webpage. If you have an interest in really studying this in depth, it's there. But in general, you can see the probabilities on the left-hand side of both of these charts, these graphs, convert to, say, a marginal risk for tornadoes or a slight risk for wind and hail. And this is very handy because it will give you a quick probability to compare with the climatological data that I just showed you, and which is also on our webpage. So if you're not familiar with the probabilities in your area, it's worth looking on our webpage and looking at the tornado, wind, and hail probabilities in your community over the course of a year. So this is a very handy tool. Again, it's on our webpage. And I'll just mention that you'll see references to significant severe. Those are the high-end tornado, wind, and hail reports that I mentioned earlier. On our outlooks, we show them with a hatching inside the probabilistic areas. But that's very important. If you really want to get a sense of, is today a day where we could have higher end severe weather potential, the hatched area that shows the significant severe probabilities is one good way to find that out. Recently, with the work of a number of people here at the Storm Prediction Center, we updated our risk communication graphic. This is also on our webpage. It's a very handy, really one-stop shopping image to show you the 5 categories that we use, what those words are, and then just sort of an overview description of what that risk means. It gives you some sense of how rare it is, how bad things can get. So it's a really useful tool for interpreting SPC forecast. I mentioned we also do fire weather. It's a bit more complex because there is no one national criteria for these terms here: elevated, critical, and extremely critical. And so you can find the regional criteria at that link there at the bottom of the page. It's also available easily on our webpage, just going to the fire weather forecast page. But we do forecast 3 different gradations of fire weather risk. Extremely critical would be equivalent to a high risk of severe storms. It's not something we do very often, and it always implies a significant fire weather event could be about to unfold. We also forecast dry thunderstorms. These are thunderstorms that occur with very little measurable rain, typically at or below 1/10 of an inch. So it gives you an idea that for lightning-started fires, which is the second most common cause after human initiated fire starts, how likely those fires might be to spread just due to the lack of wetting rainfalls. I thought I would try to.
Oh,
yes.
Sorry, Bill. I'm sorry to interrupt, but before you progress any further, I did have a question pop up that asked about your 5-category system.
Okay.
Would you be okay reviewing that right now, or do you want to wait until later?
Can you read it? Actually, with the slides up here, I can't see the questions.
Oh, yeah, sure. So Wes says, Bill, thank you for all the great information you provide us. I'd like to ask about the category or the 5-category system you currently use. Are you guys happy with the 5-category system, and are there any discussions of tweaking it? In our use on television, 5 categories is sometimes hard to clearly relay to our audience.
It's a great question. In fact, I was going to talk about it under our feature services, but I'll just address it now. And the answer is yes, absolutely. One of the things that we do here routinely is we talk with a lot of social, behavioral, and economic science experts who really provide very useful insights and guidance to us on changing or modifying many aspects of our approach to forecasting and communicating risk. One of them is looking at the words. And one social scientist said, there aren't 5 words in the English language that will have uniformly consistent meaning to everyone. And so her recommendation was a mix of words, colors, numbers, and eventually icons. But the answer is yes, we are looking at the words, how they might evolve over time, what we might change them to. We're being very, very cautious, very circumspect. Our goal is to measure twice, cut once. And so we're in those discussions and doing the research now. But yes, definitely on the table that we can make adjustments to these words, over the next few years. Great question.
Oh, thank you, Bill. One last one for this section, I think.
Sure.
So Brody asked, well, who is responsible for issuing MCDs?
The mesoscale discussions are issued by the forecasters here at the Storm Prediction Center. Typically, we have a lead forecaster and then two mesoscale meteorologists. We have a mesoscale forecaster, typically more experienced, than a mesoscale assistant who has fewer years of experience, but typically still has quite a bit of experience and educational background. The two of them work together with the lead to make sure that MCDs are issued timely for all parts of the U.S., whether it's for severe convection or winter weather, which we also do some winter weather MDs as well. But these are SPC forecasters that provide that service.
Thank you, Bill.
I'm going to move ahead to the environments page. I just wanted to give some sense of the challenges in forecasting severe storms across the U.S. And so what I have here are two images. On the x-axis, the horizontal axis is what we refer to as mixed layer CAPE. It's one of two ingredients that in a general or large scale sense govern severe storm longevity and intensity. And so the increasing instability is from left to right in both of these images. And as we go from the bottom to the top of the y-axis, the vertical axis, this is increasing effective shear. This is wind speed and directional changes within the environment of the storm itself. And these are, again, two of the factors, only two of many, but that help govern storm intensity. And if you're a forecaster, it would be ideal if all of the tornadoes that occur in each of these blocks that you see here is the number of tornadoes that have occurred in a given range of parameter space within this 6-year period. It would be ideal if these tornadoes all occurred in close proximity to each other, so that you could say, well, let's just look for these conditions and we'll have some really important insight into where tornadoes might occur. But unfortunately, whether you're looking at the left side, which is EF1 or greater tornadoes, or the right side image, which is only EF3 or greater, it is a disconcertingly wide range of environmental conditions that can lead to tornadoes or strong or violent tornadoes. And so from an SPC perspective, what this means is that while these are useful tools in helping to determine, is today a day where we might have dangerous supercell thunderstorms or an intense squall line that might have tornado potential, there's a lot more you have to look at to really refine the threat. And even once you do that, there is still lingering uncertainty, in part because through interactions between one storm and another, you can get conditions that become very favorable for just a brief period of time in a very localized area, and you can have a very impactful tornado result from that. So it just illustrates the complexity, I think, hopefully with some degree of effectiveness, that it's a wide range of conditions that we have to be familiar with here. We have to be monitoring, and we have to do that for the nation. And so it's a very challenging job, very important job, and one that we take really seriously. So how do we go through the process of issuing an outlook? Well, it starts with what have you inherited? We place a strong emphasis here on not making rapid changes to an outlook from one issuance to another. Doesn't mean we can't or won't. It just means we're thoughtful about doing that. So it begins with what have you inherited, follows with intensive diagnosis of the atmosphere, looking at lots of observations, looking at the past 2 or 3 days sometimes of radar evolution of storms on a national scale, satellite trends. All of these are important in trying to figure out what may happen today and how may that affect the severe weather potential in the days ahead. We look at a lot of numerical guidance, and one of the things that we do here that I think may be unique is we look at dozens, if not hundreds, of forecast soundings from all available models, and certainly the ones that we have found to be most reliable. Gives us a very effective picture of the three-dimensional characteristics of the atmosphere and then how that's likely to change over time. And then we collaborate internally. There's lots of experience here on a given shift. We want to bring that to bear in the process. And then we collaborate externally with local National Weather Service offices that may be affected, particularly for high-end threat days. We review it internally. Typically, the lead and often one other person will review the outlook for meteorological consistency, make sure the words are written properly, grammatical sentence structure is correct, and then we send it out, and then the process begins all over. And so it's a very complete, very focused process, because again, we know the outlook is viewed by so many people for so many different decision-making purposes. We want to make sure that we've brought everything we can bring to bear to that process. And then I've mentioned already a couple of times, and Gideon, don't hesitate to interrupt if there's questions. Going back to the earliest days of severe storm forecasting, manual analysis of information was crucial. Obviously, in the 50s and 60s, before computers were available for operational use, it was the only way to get a consistent, sort of a comprehensive picture of what was happening. But even in 2022, with automation playing such a pivotal role in all forms of operational meteorology, everybody at SPC has a pencil box. Some of these pencil boxes go back to the 70s and were handed down from forecasters who have since retired. And it's a reflection of the culture of looking at the data manually, very intentionally, getting that data in your head through a detailed analysis of fronts, temperature discontinuities, moisture boundaries, areas of pressure falls, areas of converging winds, diverging winds, and doing it at the surface and throughout upper levels of the atmosphere. There's some variation among our forecasters in terms of how much map analysis we do by hand, but certainly on the bigger days when things are changing quickly, we're all looking at especially surface maps to see how those details change over time and how that might affect our decision-making process. The forecast process is also
sorry.
Yes, go ahead.
Bill, quick question here from Rodney.
Yeah.
What data would improve forecasting the most? More mid and upper level conditions, and how might that be accomplished without endangering aircraft, or other data points?
Yeah, that's a great question. One that has no easy answer. We could use higher resolution data at the surface. We could use it throughout the atmosphere. It would be great if in certain parts of the country where the severe risk was increasing, we could target those areas with higher frequency observations. I mean, there's just so many things that I could think of, and there's not one that I could say, if we just had this is the magic bullet that would solve all of our challenges. It just doesn't exist. But I would say that, certainly over the course of my career, the changes that I have seen, and a lot of that's driven by data assimilation improvements and numerical guidance and the quality of the guidance. I've got the slide here about the convective allowing models up. They're very realistic looking, and everyone here at SPC looks at them. But typically, most of our forecasters go through a process where we look at these a bit later in the process. We're looking at diagnostic information, we're looking at guidance on the environment, and then we're starting to pull it together. And even if we sort of take a quick peek at the CAM solutions early in the process, much of the rest of the forecast process is really about validating the environments that have led to the model forecast that we've already seen. And so it's not one where we look at the CAM solutions and say, yep, there's the answer. Not at all that way. It's really bringing our collective experience, bringing what we know about severe storm environments, bringing all of that together, and then using the CAMs is an important part of that. The CAM guidance that you see here, just a couple of examples of, really is the foundation of some of the future services that I'm going to talk about as I get towards the end of my presentation. One of the tools that I would say is probably among the most widely used, not only here at SPC, but throughout the National Weather Service and even the Weather Enterprise, talking with the folks in the private sector, the High Resolution Ensemble Forecast, or HREF, or some people call it the HREF, is a really useful tool. Everyone here uses it when I work a forecast shift. It's one of my most important tools. And it began as what was known as the Storm Scale Ensemble of Opportunity, or SSEO. This is not an ensemble that was planned to be an ensemble. These were deterministic models that were put together along with some time-lagged versions of some of those models to create a sort of a de facto ensemble model but it is, I would say, it's one of the gold standards that we use here in ensemble forecasting for severe storms. There's a lot here. I could spend hours talking about it, but I mainly wanted to make sure that if you had an interest in some of the more nuanced aspects of severe storm forecasting, that you knew about the existence of the HREF, and it's on the SPC website under forecast tools. But it's an extremely important part of the process here at SPC and likely in other places as well. Here's the internal collaborative process that we go through here. As I mentioned, it's not uncommon to have 50, 60, 70 years or more of experience on duty on a given shift. And sharing of individual viewpoints is crucial. It's one of the things we look for when we hire a new forecaster, just a level of comfort, being able to be critical of other people's forecasts, not in any personal sense, but in an attempt to get to the underlying meteorology. What drove the decision process? What led to thinking this way or that way in terms of the outcome? And then, of course, that's also directed at you when you're the forecaster making that particular forecast. And so it just requires a level of comfort with that back and forth exchange. It precedes the external collaboration that we do with local National Weather Service offices. And again, both of those collaborative processes are important, but it begins with getting the most out of the staff that's on shift, their collective experiences, their inputs, and using that to make the best forecast. So what I've done here is I've animated, thanks to Matt Elliott and others here at SPC for doing that. These are all of the outlooks for calendar year 2021. I'm going to hit the start button here in just a second, and you're going to quickly see them overlaid, and you're going to see the evolution of the severe threat on a daily basis. You're going to see areas that stand out, that have more of a risk, and it just gives you, I think, useful insights into all of the different regimes that we forecast for here at SPC, whether it's in the Central Plains, whether it's monsoons, whether it's sea breeze influences. So I'm going to go ahead and start that here and watch it progress. And again, you see areas that are not surprising, of course, the Arklatex, the plains. You see a drop off west of the Rockies, but still it's not zero. You see the monsoon influence. You see terrain features in the mid-Atlantic and the Northeast, and of course in the Southeast as well. And so it's just an illustration, one year, of the variety of environments, conditions, and the progression of SPC forecast as we overlay them through a calendar year. One of the things we plan to work on is a multi-year conglomeration of these outlooks, but it's very useful. A lot of questions we get pertain to, well, what's my risk? How often do I get outlook for severe weather here? And this information is available on our webpage. It's under the year in review from 2021. So hopefully you'll find that useful, and certainly don't hesitate to follow up with us if you have questions beyond what you see there on our webpage. One of the components really of developing expertise is getting better through feedback on your forecast. And we have three different approaches that we use here at SPC in a large scale sense. And I just wanted to show them briefly to you. I'll start on the upper right, the real-time subjective outlook. This is the day after your forecast. You come in at 8 a.m. the next day. Your forecast had just ended at 12Z or 7 a.m. Central Time that morning. And so you have sort of a rough draft, a first guess of what really transpired. And so what you see there is the convective outlook. In this case, it would have been the one that you issued. You see the dots that show wind and hail. You see the tornadoes and the red triangles. You also see the gray swaths, which are lightning density. And so that's, I often call it the first draft of history. How well did you do? How well did you anticipate storm development, evolution, severity? And so it's a very useful tool. And then to the upper left is a real-time probabilistic outlook. Once we get reports in, and as they continue to come in, and often that takes a day or two, sometimes longer after the day in question, we can run this analysis, and given the reports that we know about, it will create what's known as a practically perfect forecast that you should have issued. And so you can compare that with what you did issue and really learn from that experience of getting feedback, remembering the details of the forecast, and that helps you in some incremental way to add these experiences up and to develop expertise. And then in the bottom, these statistical analyses are often bulk samples of multi-year outlooks. Each forecaster can assess their statistical reliability. Are they calibrated? And so these are important tools for all of us here at the SPC, not just to get a sense of how well I did on a given day, but the true development of expertise, which doesn't require just experience, it requires active learning from that experience. We talked about mesoscale discussions. I think these are really quite important, not just within the weather enterprise, but increasingly I speak with emergency managers who tell me that they monitor these. And in one case, an emergency manager in Illinois said that he actually has modified his severe weather operations plan to activate it when a mesoscale discussion mentions that a watch is possible or likely for their area. So they don't wait for the watch, they actually do it when the MD is issued. Mesoscale discussions at SPC fill an important time frame in the outlook to watch to warning scale. These are focused primarily on severe and winter weather. Most of them, if they're not issued to provide an update on a watch, they provide a watch probability statement. And so for folks who are sensitive to a watch being issued, this gives you an important insight into how likely that is to take place in your area. If the watch is already in effect, it provides an update on conditions within the watch area. And then one of our areas of emphasis over the last few years, and it will continue to be a focus moving forward, is once the watch is issued, using the mesoscale discussion to focus on these corridors of greater risk, higher risk potential within a watch, perhaps bridging the time between the watch and the warning issuance in that 1 to 3 hour time frame. An example of that is this particular one that's on the right side here. It was issued by Evan Bentley on December 10th as a long-lived tornadic supercell was moving into Western Kentucky. And so our goal here is, of course, warnings are issued by local WFOs, and they do a phenomenal job with that. But our focus is to look downstream, a few to several counties. Are the environmental conditions expected to remain favorable? What could cause a change in the structure and the severity of the storms? And to do that as well as we can, given that these are very small scale phenomena, they can be influenced by factors that we can't always be aware of, but to the extent we can, we try to do it. And this was a great example of a mesoscale discussion, getting out ahead of the next 1 hour time frame and providing our perspective on how it was likely to change. In this case, even with the development of other storms, it was believed that there was a high likelihood that this storm could remain tornadic and potentially very strongly tornadic as it moved northeast. And unfortunately, that's exactly what happened on this evening. Here's an example of the outlook in general. I just wanted to show one example. For our day 1 and our day 2 convective outlooks, you get individual probability hazards for tornado, damaging winds, and large hail. You also get the categorical in the upper left, which is the 5 words. And together in aggregate, hopefully you can use those to not only assess your severe weather risk, but also what are the primary hazards? Is this primarily a wind and hail type threat, or is there a significant tornado risk as well?
Bill?
Now, the success of the SPC is largely a function of the people that are here and the experience they've gained. It's kind of a unique photo, but bear with me, you'll see how I'm going to use it. This is the back of the head of John Hart, one of our 5 lead forecasters here. He's on the phone coordinating a tornado watch with parts of the Midwest, upper Midwest region. You can sort of see the watch that he's outlined there on the center screen. We coordinate with local National Weather Service offices prior to every watch that we issue to get the local expertise and local preferences for the watch counties or parishes, the duration of the watch, the type of the watch, if there's uncertainty. All these things are discussed. And one of the benefits of doing that here at the SPC is that our lead forecasters have great experience. And so this is a graph that shows in red the progression of the cumulative experience among our 5 leads. And then in the gray, their experience at SPC in any capacity. And so you can see here the retirements of key individuals, or in the case of 1994-95, the movement of the office from Kansas City to Norman, the subsequent hiring of a new generation of forecasters and their aggregation of experience. And so the point here is that these forecasters, the leads, and really all of our forecasters, are developing expertise that's quite unique, and the system that we have in place allows them to learn from these experiences and really develop the kind of national skill that can lead to difficult watch decisions on days where there may be millions of Americans at risk. And in the end, it comes down to the lead forecaster. They're supported by a staff of excellent scientists, but the pressure is on the lead forecaster to make the right call and to personally oversee every piece of information that's issued from the center here. Just wanted to quickly summarize a few of the tools that we've developed. There are many more. You can look under forecast tools and see them. Probably the longest lasting one has been the SPC mesoscale analysis, which goes back to the very early part of the 21st century. This is an example that shows a relatively new development. It's the ability to look at photographs across a region that's covered by the mesoscale analysis domain. On the upper right is the sounding climatology, which is very useful in getting a sense of how unique or commonplace the upper level sounding data is for a particular area. In the lower left is the HREF, the high resolution ensemble forecast that I mentioned earlier. And then on the lower right is the web-based sounding analysis program that's on the SPC webpage. So one of the things we do here when the weather's quiet is we try our best to advance the science. It could be with tools such as these and others. It could be applied research, many different ways that we can contribute beyond our forecast. One of the other ways is in the extensive publications, which is all on our webpage. This is just since 2000, which gives you some idea of the areas of focus and our collaborative nature. We never really have a true off season, but typically in the late fall and winter, it is quieter. And so we can make a lot of work, a lot of progress on these collaborative topics that are the focus of our research efforts. And then the hazardous weather test bed is an important dimension of what we do here in Norman, in this building, and within the NOAA offices that are here. There are two components, the experimental forecast component and the warning part. Many of the improvements that you see in the convective allowing models, in the tools that the SPC uses and that we share, were originally developed and tested and refined over multiple years within this test bed environment. And so because it sits in the room that's in between the weather forecast operations area on the left, I don't know if you can see my cursor, and the SPC operations area on the right, it's uniquely positioned to really bring all of this expertise and visiting forecasters, modelers, researchers into this room for 5 days. And we do multiple weeks each spring to give them a sense of what it's like to be in the hot seat and to have to make these forecasts, and hopefully to contribute to the development of the tools that allow us to do it even better. So real quickly here at the end, some of the things we're focusing on. One of the dimensions to severe storm risk that are currently not adequately addressed in our convective outlooks is timing. And this, on the left side here, you'll see hail and wind and tornado reports in Kansas for the course of a convective day, an afternoon and evening into the overnight hours. On the right side, we break them down into these 4-hour groupings. Most of the severe weather that occurs in the US can be adequately captured in a 4-hour time block. And so if we can take this knowledge of the severe storm report environment, use these high resolution convection allowing models, and combine that with the forecaster skill, what we hope to develop is timing guidance. And so this is one example of, this isn't even done operationally. This was just a proof of concept using isochrones of similar time of arrival. The challenge here would be if you have multiple rounds of storms. And so while this is one tool that might work, to give you a graphical sense of where the threat will start and how it will evolve over time, one of the areas that we are currently testing is using these time series that would, let's say, allow you to click on a map and see for your location how the threat would evolve over time, both for all the hazards, tornadoes, damaging winds, and large hail, and when it would increase, decrease, when it would peak. We are actually testing this internally on a web page that's available for National Weather Service offices. It's useful for them right now in developing impact-based decision support. But let me show you an example here. This is from the December 10th, Mayfield, Kentucky, the deadly tornado. Here's the sequence of the evolution of the supercell over the course of 8+ hours, over 400 miles. as it moved from northeast of Little Rock across western and northern portions of Kentucky. Here's the time series for Mayfield for that day. And this was based on the model guidance from that morning. So it would have been available in real time. And you can see the increase in the probabilities. We've gone ahead and put in when the tornado watch was issued and when the tornado actually occurred in the bright purple there, and when Mayfield was hit. And so you can see that conceptually, this could be very useful to provide information to an emergency decision maker, a citizen, a business who might be concerned about when the threat might ramp up, when it peaks, and when it might start to subside in their area. So we are working on this and expect to hear more, hopefully in the next few years. We're also working with FEMA. We have an on-site FEMA liaison, Dr. Summer Erickson, to take our forecast and to convert them into impacts modeling information. This is the April 27th, 2011 super outbreak. And using information about how past tornado outlooks that we've issued have verified, we can compute a range of probabilities, whether it be for mobile home exposure in the lower left, number of people potentially impacted, a range of tornadoes that might be expected. This is reasonable best case and reasonable worst case in these examples. The potential impacts to electrical power stations, hospitals. I mean, there are quite a number of different ways to interpret it, but these are things that we're working on. The goal is turning risk communication information into actionable impacts type information. And so with that, I wanted to say thank you to everyone who's on the webinar today and appreciate the questions I've already gotten, and we'll look forward to the discussion. And don't hesitate to reach out if there are questions that you want to follow up with. And of course, in addition to our website, we are visible on Twitter and Facebook, and hopefully you'll find that information helpful as well. So Gideon, I'll turn it over to questions. And again, thanks.
Hey, thank you very much, Bill. We do have a bevy of questions available here that I kind of didn't know where to fit in properly. So I'll just go down the list right now, if that's all right with you.
Sure, absolutely.
All righty. First up, actually most recently, Natalie asks, how do SPC storm reports feed into the NCEI storm events database?
Great question. Storm reports that we show on our webpage originate from local National Weather Service offices. They issue something called a preliminary local storm report, or we often abbreviate it LSR. So we just aggregate those reports that are issued by local offices. Those reports are often sent out in real time. And so there may be duplicates or aspects to those reports that, in the interest of getting it out quickly, they would have to follow up the local office and correct those reports or make them ready to be published within storm data on the NCEI webpage. And so you can sort of view it again as that first draft of what occurred with the severe weather event. But the local office, the meteorologist, the staff there have about 3 months to get the final version ready to then share with NCEI, and that's when it becomes finalized as part of the storm data record.
Excellent. Thank you. Thank you very much, Bill. Ernani asks, how is the coordination with the NHC when it comes to the issuance of tornado watches associated with a hurricane making landfall?
Yeah, excellent question. We meet with NHC and all of the affected National Weather Service offices and many others in a conference call about an hour or a little less before the NHC advisory comes out. All the hazards are discussed, led by the NHC specialist on duty. And one of those, of course, would be the tornado threat. They typically go to the SPC, and then we provide a quick overview of our thinking. We've already provided them a statement, a tornado statement for the advisory that's being issued. We discuss any changes that need to be made. And then it's included in the advisory that NHC issues. So it's a collaborative process, and it's done routinely before all of the 6 interval public advisories.
Excellent. Matthias Bill asks, you talk about looking downstream. How much, if any, does Mesonet data from states like Oklahoma and New York play in your analysis?
I would say where it exists, it's absolutely crucial. Obviously, the more gaps we can fill in with quality atmospheric measurements is to our benefit, and not just to ours, but to the weather community in general. Those benefits go beyond meteorology. It goes into transportation and agriculture as well. But here at SPC, the states that have these denser array of networks, mesonets, We have all the data that we can get into our IT systems here. Our IT specialists do a great job at keeping our systems running and as much data available as possible. And so the more data we get, the better. As these networks expand, we're excited to get access to the data and just fill in the void with information that's frequently updated, very high quality, and it just helps us to know what's happening now so that we can anticipate how that's going to change in the hours or even days ahead.
Thank you, Bill. And Steve asks, what interval or hours for manual analysis is used, and can you use 1 hour intervals in METAR reports?
Oftentimes it's 1 hour intervals. We can look at special observations that come in. We can fill that in with high resolution satellite imagery, radar data, but typically we'll run a surface plot shortly after the top of the hour, after the data have come in for that hour, and we'll do an analysis at that point. But again, when things are changing quickly, and those are the days where we know that we need to look sub-hourly, we'll look at any higher resolution than 1 hour interval data we can get our hands on to see how the atmosphere is changing and really how that's going to influence our forecast.
Great, thank you. And Rick asks, how does SPC involve the WFOs in the forecast and dissemination process?
Typically, of course, we have chat, we have phone calls are the dominant ways that we use to chat. I would say the chat component is probably the most frequently used. Part of that is because if you pose a question in a chat room, other offices will see it. Most of our collaboration is focused on higher end days when the consequences may be greater, but offices reach out to us at any time, at any point in the process, really, and we'll do the same. It could range from today's forecast to 1, 6, 7 days into the future. And so it varies with the forecast complexity and the offices that are affected, but we sort of have a open door policy. There are timeframes that are preferred by us in terms of the forecast process for offices to reach out. But I think just looking back at last year, we had over 3,500 documented in our shift log instances of collaboration with local offices. So it's something that we certainly do frequently.
Wow. Oh, thank you.
Sure.
And Bill Norman asks, are there plans for warnings in other languages, for example, Spanish? And also, is there a category for thunderstorm based on flash counts?
I'm not up to date on efforts to convey warnings in other languages. That's a great question, one that we could certainly get more information on and get back to you. There is work that's been done and continues to be done here at SPC on lightning density. Specific warnings, the question is often asked, why don't you issue warnings for lightning? Warnings for lightning would amount to warnings for every thunderstorm. And so, in our safety and in our outreach, we try to make clear that any thunderstorm has a risk from lightning. If you hear thunder, of course, you need to go indoors and take action. But I think as the science allows us to provide more quantitative and certainly more accurate information regarding lightning frequency, we're going to convey that publicly. It's just a matter of doing it with skill and doing it with routine skill that we want to make sure as an agency. I don't know that it would come necessarily from the SPC, but the National Weather Service will certainly continue to do all we can to get information out that helps keep people safe.
Great, thank you, Bill. And
Sure.
probably our last question, because of time, this one comes from Rodney. Rodney asks, are the 2 new supercomputers operational and contributing to forecasts now?
Yes, and we are in the process of wrapping up the transition to some of the newer supercomputing capabilities. And computing capabilities, it's an aspect of the science. It's a good situation, but they're improving. High performance computing is always evolving, advancing. And so as an agency, we just have to make sure we're taking advantage of those improvements and using them to get the data we need to make the forecasts that are so crucial.
All righty, excellent. Well, Bill, thank you so much for everything. I think we're about reached the limit for our webinar today. Ladies and gentlemen, we'll make this video available to Weatherband members at amsweatherband.org and at ametsoc.org. If you want to talk about the webinar, members are welcome to discuss on the Weatherband Community Forum. Also, I'm going to put this in the chat if folks are interested. Consider joining our AMS webinars mailing list. That is in there. But yeah, Bill, did you have anything else to include for the conclusion?
Just again to say thank you to everyone who attended. These were great questions, and don't hesitate to reach out, and certainly do all we can to provide the information we can. Thank you.
All right. Well, thank you so much, Bill, and thank you everybody for joining us today. This concludes our webinar. Have a great remainder of your day. Take care, everybody.